Okay, there is not so much that I can do while this is installing the library. And it's pretty much taking time because I have SciPy and Plotly that needs to be installed in the environment. Oh, clone. So Maria, you asked the clone. And so you remember, I don't know if you were in the previous sessions, but if you're working with this this repository, one thing that you can do is clone the repository using Git. So this is the link to the whole repository, to the Git, to the repository in GitHub. So when you clone it, you're effectively making a copy of that repository in your machine. So when the repository changes, you can actually update your clone repository onto the machine. So if I try to do it, let's try to do it in another folder. I don't want to spoil that particular folder. Oh no, not the wrong power. So let's say I have a folder called, let me make a folder here, and I'm going to create a directory called Maria, just for the sake of example. So there I have a folder called Maria. So one thing that I can do a Git clone and then copy the link that you saw here. I'm gonna copy this link and paste in here. And by doing that, now you can see that it's saying cloning. So that folder, Maria, that was empty before, now has the PyThon folder and all the code. So if I go into cd Python and I do a list, I hope you can see it, but you have the folder DCA, foundation, and material balance there. So if I do cd material balance, you will see that the notebook that we're going to use later on today, it's in there. Okay. Any other question? Is it clear? Is it clear, Maria? And I think that you can do things like git pull, and git pull will try to bring any changes that you have done on the library from the previous time that you used the repository. It's taking time, but it's progressing. So this is quite useful, for instance, when you're working with a library that is continuously evolving and you just want to make sure that you are up to date. You can just clone the library, and when you see that there are changes, you can pull the changes. You don't have to clone it again, so you don't have to have like multiple copies of the library. And at the same time, I believe that Git it's keeping track of all the changes across these versions that you are using. Any question? Okay, so this has been completed. So if I do pip list, so I see the list of the libraries that I have installed so far there. You see that I have pandas, numpy, plotly, SciPy, and I have also the RE material balance library. So one more thing that I need to install in the environment is, and this is also different to what you have seen before, I can do pip install, and I'm going to do Jupyter Lab. That may take also a bit of time, but now I'm going to, whenever I call Jupyter Lab from that environment, I'm going to be calling the Jupyter Lab and the libraries that are installed in that environment. Any more questions while this is running? Was that clear, Maria, on the cloning? Oh, sorry, I just read that there are more questions. There is a question about, I see that the package that you install, it's called re-matval. Is there any way to modify the packages in general, install them again after modification? Yes, you can uninstall the package, install it again. But if you want to work with the source code, the thing that you could do, it's clone. You can clone the whole repository. And you can work with that repository with the source code yourself. Sorry, Maria, I was asking you because I did my chat was not updated. I saw it later on. So Felix asked, do we have to install Git into PowerShell previously, or does it have to? No, you have to install Git in your machine, and it will be available when you install Git. It will be available across the command prompt or the PowerShell. So yes, you have to install Git first. Otherwise, you won't be able to clone the repositories. So I think I've gone through some of that in previous sessions, but just as a reminder, you can go into the web page of Git. So if you Google for download Git, and you will see there the different versions of the Git that you can install. So once it's installed, you can use it from the command line. You can use it from the Ubuntu terminal in Linux. Yes, absolutely, you can use it there. And okay, so this is still installing. Hopefully, it will be quick. Any more questions? How to install the modified package? So okay, yeah, but who is modifying the package? So is it you that are you the one modifying the package? So if the package, let's say, has evolved, I believe that you can do a pip update. So if let's say for instance you have a version of pandas that it's not the latest one, and you can do a pip update. Let's say I'm here and I want to do pip update pandas. I think I can do something like that, and this will bring the pandas version that I have to the latest version. Oh, it's not update or upgrade. Or you have to do pip install pandas, and then you can do upgrade. I think that's the other way in which you can do. Right. So still installing here the Jupyter Lab. Is taking a bit of more time than I was anticipating. But I think it's good to cover this point from the ground so you understand uh, how to install how to manage your environments and how to install libraries in every one of the environments. And also understand that when you are using Jupyter, you are using the Jupyter and the libraries that are in the environment that Jupyter is running on. So whether you do it with the PowerShell and you use pip, or whether you're using Anaconda that is using the Conda package manager on the background. So while that is running, what we want to do with this Excel, it's load three tables. Okay, I have another question. Do we have to make a pull request to update our Git repositories without cloning them again? Yes, that is advisable. And just make sure that if you are editing your student files and you're making your own files, you merge. You have to do a merge of the changes. You don't want to replace your student files with the ones that are in the repository. You want to keep your own, I guess. So that's it. That's the only thing. So one way to do it is when you download the student files. When I mean the student files is for instance, in DCA, there are student and instructor files. So these files are the ones that I originally put there with the questions. So if you are editing those, the best thing to do is save those as your own files. So when you do an update or a Git pull, when you do a pull, you are not replacing your progress with what is on the GitHub repository. Does that make sense, Felix? Okay, cool. Oh, this is taking a lot of time. So we are going to load the oil PVT. We're going to load pressures, oil formation volume factor, and the gas oil ratio. You have a plot in there. It would be interesting if you at some point put a plot as well in Jupyter. For the PVT, we're going to load the pressure set and VG, the gas formation volume factor. I'm going to import it directly from this one. And from the calculations, we're going to import the days, the cumulative oil produced, cumulative gas, cumulative water, and the observed pressure. It's meant to be like an average pressure of a reservoir pressure that was measured at some point of a production history of a field. So these values, we are going to set them up manually in the library. Okay, it seems that this has been already installed. So I'm going to run Jupyter Lab, and hopefully it will come up with a Jupyter Lab instance. Let's see. Okay, there we go. Okay. So this is where we're going to start to code. And this is more or less what we want to achieve at the end of the exercise. We want to import all the data, and we want to do a couple of plots here where we can have a look at the drive indexes and the basic plot with a pressure distribution. I don't know what's happening here. This is not loading these plots, but I'm going to create a new file from scratch, and I'm going to call it. Let me close this. This file I'm going to save. I'm going to close this, and this I'm going to close. So I'm going to open a new notebook, and I'm going to call it oil reservoir example 1, and this will be like a student version of that example. So the first thing that we would like to do it's actually explore the data. So let's have a look at the data, and as you know in the Excel, let's start loading this particular few cells. So in order to do that, you know that you need to use pandas, and usually most of the people use the pseudonym of PD for pandas. And so what we want to do now is start to import the Excel. Just let me make a copy of this, just a second. Just a second. Okay. So we want to import it into a production data frame. So let me put some comments here. I'm going to put a markdown here, and this is going to be import data, and this is import production and PVT data, right? And for the next one, I'm going to put another markdown where I'm going to label import production data. Okay, so one of the important things that you need to know is the data frame should have some columns here, and I'm going to put the name of the columns that we need to have. We need to have to use the library. We need to have days, date stamp, the cumulative oil, cumulative gas, water, cumulative injection of water and gas, and a pressure, observed pressure. Okay, so just to make sure that that's what we're going to have at the end. So the file that we will be loading, it's under data, LSU, mval, so it's data, LSU underscore matval / oil MBE dot XLS mvex.xls. And in order to load it into a data frame, I'm going to call this the data frame prot. And I'm going to do pd dot, let's see, read Excel. And, oh, let me increase the size of the screen, sorry. Is that better? Hopefully. So pd read Excel, let's load that file. And if we remember the name of the sheet that we're going to use, it's called calculations. So I can put sheet underscore name equals calculations. And I'm going to load it like that, but just to show you what's going to happen, and because this is not good, what's going to happen here, right? Okay, so there is one dependency that is missing, that it's XLRD dependency. So we need to import a dependency so that we can import that Excel. And one thing that you could do, it's import it directly from here. But another thing that you can do, it's also open a command line, another terminal here. This is similar to the terminal that we have in the PowerShell. Just to give you another option, but now you have this terminal. And if I do pip list, oops, that's not the environment that I'm working on. So yes, you need to be careful. This is not working on that environment. So I'm going to go back to this environment here. Since I am running already Jupyter, I don't want to kill Jupyter to install the library. One thing that I can do, it's install it directly here. I can do pip install XLRD. Oh yeah, Mari, the file is incorrect as well. But I need the library to read the file anyways. So now the library it has been installed. So let's see if that runs. Okay, that run now. I have the library installed. And this is to show you that if you want to run a command with exclamation mark, I'm running the command. In fact, I can do now the list here. And you will see that XLRD, oops, this is showing many. Oh, of course, right. Where is my RE? Okay, my RE and matval is here, and my XLRD is here. So I'm going to remove this line, here output, and I'm going to remove this cell. And what's happening here, if I show you the header of the file, this is not something nice. What is happening, it's loading the file from the top. So on name columns, and it's trying to load every one of these columns. So that's not what we want. We want to load actually from this point downwards. So one thing that we can do is skip some of the rows and skip some of the columns. And for that, we can use skip rows equals 12, because we know that we don't want to read any of these. And the number of rows that we want to read are only around 73 rows, okay, based on what we see on the Excel. We want to include only 73 rows. So we're going to skip the first 12 rows and we're going to read only 73 rows. So if I do the header now, that's fine. Yes, it's in the first column. That's fine. We're going to get rid of some columns later on, but I'm having at least the file or the header as we want it to be. So if I want to know exactly which columns I have, I can do dfprod.columns, and let's convert this to list. And there you go. These are the columns that we have in the file. And as I mentioned, we only want days, date stamp, NP, and these have to be the names of the file, because otherwise the material balance library is going to fail. So we have to use those files. So let's do some more edits. So I'm going to do here let's clean the data frame and remove some columns. Remove and rename some columns. Okay. So in order to do that, the first you can use the function rename, and you have to tell which columns you want to rename. In fact, you have to provide a dictionary with the equivalent name of the columns. So let's put the dictionary names, and we're going to do I want this column to be named NP, as it is required by the library, NP. I want this other column named GP. The produced water has to be called WP, and I think that we also need to convert this to pressure. All right. So now I can use this dictionary and say columns. The columns now will be called based on the dictionary names. Now, notice something, and if I do this, you will notice that nothing is actually happening. So you have two options. You can do this, dfprod is equal to this, or you have another more elegant option, which is the in place, and you can say in place equals true. So if I do in place equals to true, and let me do then print the header. Now I have my days, NP, GP, WP, and so on. Another thing that we need is a date stamp. And so I'm going to add a date stamp using start date. This is a completely, let's say, a fictional start date because in the Excel we don't have a start date. But I can do, now let me do it here, just after this. I'm going to do start date, and I'm going to use a library datetime to say the start date is, 2010, January 1st. Now this is going to fail, of course, because I don't have the datetime library. So again, I have to install the library. I show you how to do it. Now I'm going to try to install it with the terminal. I believe the terminal is actually connected to that environment. So if I do pip install and we do datetime. Well, first of all, if I do import datetime. Okay, sorry. Datetime is a standard library of Python. I don't need to install it. Okay. Start date, datetime. Object is not callable. Datetime. Oh, sorry. Datetime date. Right. There we go. And the other thing that I'm going to do is I'm going to add a column to the production library called date stamp. And one way in which I can populate that column, it's I can populate, for instance, an array where I can say, let's say I want to do something, like I want to do an operation that says for day in df prot days, and I want to put a date for this column. I want to add a column date, a column date stamp. So for every particular day of this column, I want to do an operation, and the operation that I want to do is datetime dot time delta is going to convert this item day to a time date delta, and I'm going to add the start date. So what's happening here now? If you see now, I have a column date stamp starting on the start date, which is 2010, January 2010, and for every day, I'm adding for every row, I'm adding the number of days to the date. So ultimately, I have a column with the dates. And I have to do that because the library requires you to have a date on the column. Right. So some other stuff that we're going to do, because the library requires also water injection and gas injection, and there is nothing on that. There is no water injection or gas injection on the case. So what we're going to do is set up water injection and gas injection to 0. So for that, I'm going to do water injection. If I just simply assign 0, you can notice that the whole data frame has been populated in water injection with zeros here. Okay, so I'm going to do exactly the same for the gas injection, and for the gas production, something that you will also need to do it's convert the gas production to, at the moment we have thousands of standard cubic feet thousands of standard cubic feet, and we have to convert it to a standard cubic feet. So we're simply going to multiply by 1,000. So now that has been multiplied by 1,000. To make sure that I don't write that code again, because that's fine. Now the last thing that I'm going to do, it's well, I can remove some of the columns, and if you want to remove or you want to keep just few columns, one thing that you could do, it's you can say, well, the df file or the data frame is equal to the data frame itself, and you have to, with a double square bracket, you have to specify which columns you want to keep. So in this case, it's only these columns. This is an optional step, and I'm going to put it here. This is just a optional step, just to keep the columns that the RE val library will be using. And there we go. This is much more cleaner. Only the data that we will use for the calculation. So moving on, let's import the oil PVT. For the oil PVT, let me just copy the items that we need to use for the oil PVT, which are so we only need for the oil PVT, or let's say import PVT. We need, for the oil PVT, we need pressure, formation volume factor, and solution or gas oil ratio. And for the gas PVT, we need the pressure and the formation volume factor of the gas. So same story here for the oil PVT. We want to import just this table here. So we want to use similar import that we use in here. I don't need to define the file again. The file is exactly the same. In fact, let me just put this in here. The file is exactly the same. What I'm going to do is just import the oil PVT spreadsheet. And we need to skip 3 rows and only load 17 or 16 rows. So let's skip 3 and load 16. And there we go. So everything looks okay. I have pressures, BO, RS, and so on. And I'm going to do exactly the same. I'm going to have a dictionary where I'm going to replace some values. So my dictionary name now will be pressure. I think I need to convert BO. And I think I need to convert RS. I'm just going to reuse the same variable dict name, and I'm going to put oil PVT just to be a bit more to avoid to replace a variable. So the oil PVT, and we need to replace those with pressure, oil FBF and solution gas. So this is pressure, oil, FBF, solution gas. And of course, we don't want to use dfprot. We want to use a different name for this one. I'm going to use PBTO name. And I have to rerun this because I've replaced those already. Boom, boom. And just to make sure that everything looks fine, let's see how the header looks on the file. Here we go. We have a pressure, oil FBF, and solution gas. And if we want to also make sure that we only keep the columns that we want here, just let me clean the file a bit more. Oops, sorry. So we can do data frame, PBT oil, and we want to keep only pressure, oil, FBF, and solution gas. So this is the only columns that we want to keep in here, I believe, and that's fine. Let's have a 10 minutes break. I'm going to be here, but if you have more questions, let's have a quick break, and we'll come back in a second. So I'm going to stop the recording and then start the recording again. If you have any questions, I will keep here. I see some questions in the update.